Here we have another example of a rational inequality. We have 4 over x minus 6 is less than 2 over x plus 5. So one of the first things we have to do is we have to get everything onto one side of the inequality. So the easiest way is to just move this fraction over here to the left. I don't know what it is about that, but I just feel better when everything's on the left side of the inequality, or the equation for that matter. So this is the first step. Really nothing too big going on here. But then we have to get everybody to be a single fraction. So we have to find find the common denominator. So we look here and we see that these guys are already factored, nothing big going on. And this denominator is missing the factor of x plus 5. And we have to put that in the numerator as well. And over here we're missing the factor x minus 6. Now, one of the things you're going to notice that's a little bit different here than what we had with rational equations is that we cannot just eliminate the denominator. The denominator is a very important part of this rational inequality. So when these guys combine, it's all going to be over what is now this big common denominator of x minus 6 times x plus 5. And this is still less than 0. We just have to figure out what's in that numerator. So off to the side, let's do some scratch work for that. So we have 4 times x plus 5 minus 2 times x minus 6. So go ahead and distribute. So we have 4x plus 20 minus 2x plus 12. Make sure you watch your signs. Distribute very, very carefully. Combine like terms. So we end up with, what is that? That's 2x plus 32. All right, so my big numerator here is 2x plus 32. So we have everything combined into a single rational expression. We now need to identify those critical values. So remember, the critical values will be anything that makes either the numerator or the denominator 0. In other words, anything that makes any of these factors equal to 0. So starting up here, if off to the side you were to work this out and say, all right, 2x plus 32 equals 0 when what? Well, 2x equals negative 32, which means x equals negative 16. So one critical value is negative 16. And then we get the critical values from these factors in the denominator. That's 6, and from here we get negative 5. Now, just like I did in the last example, I'm going to put little stars here for these guys. Those stars indicating that they came from the denominator. Since they come from the denominator, it's not just that they are critical values, but they become restricted values, and they can never show up in the solution set. All right, and so now we're going to make our sign table with all three of these factors. So 2x plus 32, x minus 6, and x plus 5. And we're going to see what happens when we put all of these guys together. Now, I really should put my entire expression down here, but I'm kind of running out of room. Well, I guess I can squeeze it in. I got really good at writing really small when I was in high school. But I since changed that since other people needed to read what I was writing. All right, so we have 3 critical values. So we've got 3 divisions here, which is going to create 4 different sections to check out. My critical values, when I put them in order, I have negative 16. The next number is going to be negative 5. And then finally, I have 6. You've got to put these guys in order from least to greatest as you move from left to right. So one factor at a time. The critical value for 2x plus 32 is negative 16, which means he's going to be negative before that and positive in every section thereafter. For x minus 6, his critical value happens over here when x equals 6. And since he has that positive lead coefficient, he's going to be negative all the way and then positive on the other side of that critical value. For x plus 5, the critical value is here at negative 5, so he's negative before and positive after that. And then we go through and we do what we've been doing, right? In that first section, you've got 3 negative factors. So 3 negative factors is going to give you a negative result. When you have 2 negative factors, that becomes positive. 1 negative factor is negative, and then finally, where everybody is positive, you're positive. Now, these critical values that I had starred, 6 and negative 5, so 6, put a star for this guy, negative 5, put a star for that. So right now, we can go ahead and say that when you have these critical values that came from the denominator, that means you would have zeros in the denominator, which causes you to be undefined. I'm going to go ahead and write that so that we remember that that's there. Remembering that it's undefined and knowing that it's never going to be part of our solution set. Now the 0, the critical value that we get from the numerator, negative 16, is going to make us 0 at the end. Remember, you can have 0 in the numerator. You just can't have 0 in the denominator. This inequality here was looking for those values where you are less than 0. So we're looking for just the negative regions. So right here and right here. Notice there's nothing that says you could be equal to 0, so we won't be able to include any of these endpoints. We couldn't include these anyway because they would have made the expression undefined, and negative 16 would have made it equal to 0, but the inequality doesn't allow for that. So my regions will be everything that's here to the left of negative 16 and the stuff that is in between negative 5 and 6. So the interval notation, we go from negative infinity to negative 16, parentheses, you've got the gap, so we use the union sign, and then it's negative 5 to positive 6. Again, everything with parentheses. As we've mentioned before, the sign chart doesn't change because of this guy right here. So whether this were less than, greater than, or equal to, any of that stuff, you would still have the same sign pattern at the end. But since it's less than, we're looking specifically for those regions where it's negative.